Okay, so this is exercise 4.11 and it's based on find the limit of t of n as n goes to infinity. So what we're looking at here is basically, if I was to write down what t1 is here, it's going to be 4 times 1, which is 4, plus 1, 5. 5 over 3 times 1 minus 2, it's going to be 5 over 1. t2 is then going to be 8. 4 times 2 plus 1, which is 8 plus 1, which is 9. Over 3 times 2 minus 2, which is 9 over 4. Okay, now what I can do is I can keep doing this over and over again. I can go up to t 1,000, I can go all the way up to t a million. Okay, and what we're trying to find out is there a limit to how big this is going to get? Does it turn into a single number? So an example would be if I was to put this formula in, and this is for all the terms, right? So if I was to put this formula into the table function, for example, okay, and I was to say, okay, for n, so just press the fraction button at the start, table, and I was to say, for example, 4x, 4 shift x, 4x plus 1, divided by 3x minus 2. Minus 2, okay. And then I could start out 1. I could end at, I don't know, maybe 1,000 or 10,000, and go up in the step of 1,000. Okay. Now what happens here is this. Look at this. Okay. 1 is this one. Term 1001 is 1.3345. Term 2001 is 1.339. And then we can see 1.337, 1.336, and when you see that as the terms get bigger, they're changing less and less and less. You can see there's practically no change in the term, so it's converging on the value 1.333. Okay, so if I was to redo this again, exactly the same thing. Start at 1, end at 10, let's say, and go in steps of 1. You can see that there's much bigger changes between T1 and T2 and T3, but the change gets smaller and smaller and smaller as you go down. So the difference between T7 and T8 is quite small. T8 and T9 once again quite small. So what we have to do is, in questions like this, we have to find out what's called the limit of Tn. So we have to find out the limit of Tn as n approaches infinity. Basically, as you get more and more and more terms that are really big, like term 1 million, term 1 billion, okay, and you'll find that the resultant value will actually get close to 1.33. So what we're going to do is we have 4n plus 1 over 3n minus 2. What's going to happen is we're going to replace n with we're going to have to divide. In these questions, you divide by the highest power of n. So the highest power of n in this question is n to the power of 1. So what we're going to do is we're going to do 4n divided by n plus 1 over n equals 3n over n minus 2 over n. So we divided the top and bottom by n. Once we've done this, what we're going to get is 4 over 3, and then it's going to be plus 1 over n, and then minus 2 over n. And that's once again the limit ln Tn as n approaches infinity. Now, as n approaches infinity, what we can say is that it's going to be 4 plus 1 over infinity, and then 3 minus 2 over infinity. Now, when you divide a small number like 1 by a really big number, or a small number like 2 by a really big number, they turn out to be 0. So the answer to this is 4 over 3, or 1.333. That's basically our maximum value. It's going to converge to this value and never go below it. Okay? So, next question, which would be question 5. Okay, so remember, you always divide by the highest power of n in these questions. Okay, so once again, exactly the same question, question 5. Now I'm going to divide the top and bottom by n squared. So I'm going to get the limit of Tn as n approaches infinity, and we're going to get 3n squared divided by n squared minus 4n divided by n squared 7n squared divided by n squared, and plus 2n divided by n squared. Now what we see, the result is going to be 3 minus 4 over n, and that's going to be 7 plus 2 over n. Once again, we can see that when you sub in infinity, so limit Tn as n approaches infinity, so n is going to get really, really big, so it's going to be 3 minus 4 over infinity, 7 plus 2 over infinity. And we see that these two here can all turn to 0 because they're a small number divided by a really, really large number, and the answer therefore is going to be 3 over 7. Okay, moving on from there, we got question 8. Now in question 8, it's going to be Tn equals 1/5 minus 1 over n plus 1. So in this question here, we can see there's not really much to do. Okay, so as the n value gets bigger, so as n approaches infinity, what's going to happen is this value here is going to approach 0 because the denominator is going to become so big. So we're going to end up with Tn equals 1/5 minus 1 over infinity plus 1. Now, infinity plus 1 is a massive number. 1 divided by a massive number is, in all intents and purposes, 0. So, limit of Tn as n approaches infinity is going to be 1/5. Okay, so that's a handy enough one. So that's 2, 5 and 8 done. Now, 2, 5 and 8. And then we'll go for 11, 14 and 17. What did we do there a second ago? 2, 5, 8. So we've done 2, 5, 8. Now we're going to do 11, 14 and 17. Now, what's going to happen here is we're going to have 3/5. So Tn equals 3 halves minus 1 over n plus 1 minus 1 over n plus 2. So in this question here, once again, you're going to do the limit as n approaches infinity. The n values are located on the bottom, which means they're in the denominator position, and it's just going to be 1 over infinity plus 1 minus 1 over infinity plus 2. These numbers are so big that once again 1 divided by them turns into 0 and a 0, and what we're going to get is 3 over 2. Okay. Now the next one is going to be the next one here, question 14. It's going to be Tn equals the square root of n minus 1 divided by square root of 9n plus 4. Okay, so the thing to remember here is that once again we're getting the limit as n approaches infinity. Okay, so n is the biggest value, biggest power. It's on the top and the bottom, so we got to divide by n. Okay, or we're going to divide by n inside the square root sign even. So we might even divide by the so we're going to divide by maybe even the square root of n, because if we divide by the square root of n, we can put it inside the brackets, because you remember correctly, an old rule would be I don't know, root 25, sorry, divide something like this, root 36 divided by 6, root 36 divided, alright, sorry, just taught this different way, okay. If you imagine root 26 minus 1, and I had to divide that by root 5. Okay, so what you're technically allowed to do is you're allowed to join, so it's going to be 26 minus 1 is 25, and you're allowed to join the two root signs into 1. Okay, so if I divide the top and bottom by root n, what I'm going to get is this root n minus 1 divided by root n divided by what's it going to be then? It's going to be root 9n plus 4 divided by root n. Okay, and now once I've done that, what I can do is I can join them into the one fraction. So it's going to be square root of n minus 1 all over n, and this is going to be the square root of 9n plus 4 all over n. Now once I've done that, I'm going to work on the fraction. So I'm going to break up the fractions on the inside. So it's going to be n over n minus 1 over n, and then on the other one it's going to be square root of 9n over n plus 4 over n. I just broke up the fraction, okay? And once again, this is the limit of Tn as n, it goes to infinity. Okay? And once I'm done with this label here, bring it down, and then equals this. Now I'm going to replace n with infinity, and what I'm going to get, that's going to be 9, and that's going to be 1. And then when I replace n with infinity, that's going to be infinity and infinity, which is in fact 0 and 0. So you're going to get the square root of 1 divided by the square root of 9, which ends up to be 1 over 3. Okay, so now we're going to try question 15 as well, because in question 15 we have to figure out what square root of 4n squared minus 1 is, okay? So for question 15, for question 15 we have the square root of 4n squared minus 1 all over n plus 3, and this is the limit as n approaches infinity of t of n. Now what I want you to zone in on is the fact that if this was n approaching infinity, this number here becomes really significant in comparison to the minus 1, as does the n. So in effect we would be dealing with the square root of 4n squared divided by n, which is going to be 2n over n, which equals 2. Okay, and that's going to be our limit. Now we're going to use the same technique we did before, but this time around we got to look at how we're going to do this. Okay, so it basically means if it's basically the square root of 4n squared, it's basically to 2n. This means the highest power is n. Okay, so I'm going to divide the top and bottom by n. So we're going to have the square root of 4n squared minus 1 all over n. Then we're going to have n plus 3 all over n. Now, in this one here, what I can change this to, because this is a square root sign, n equals the square root of n squared. So I can do the square root of n squared here. Okay, and now we're going to break up the fraction. So we're going to have a square root of 4n squared minus 1 over n squared, and then on the bottom you're still going to have n plus 3 all over n. Let's break up the fraction. So it's going to be the square root of 4n squared over n squared minus 1 over n squared, and then it's going to be n over n plus 3 over n, and then as n approaches infinity we'll just cross off. So that's a square root of 4, that's 1, that's going to turn into 0, that's going to turn into 0. Limit as n approaches infinity, because the n's will turn into infinities. And then we're going to be left with the square root of 4 over the square root of 1. The limit is 2. Okay, so that's question 15 done. Now we're on to question 17. Okay, so question 17 is the same deal. What we're looking at here is the limit as n approaches infinity of Tn. Now, once again, square root of 2n squared is the significant part, and so is n. And when we square root it, it's going to be square root of 2n. So we have to divide top and bottom by n, because n is the biggest power. So what we're going to get, we divide by n, Remember, n equals the square root of n squared from the last question. So what I can do here is this. I can say that it's going to be the square root of 2n squared plus 3 all divided by root n squared, and now I'm going to have n over n on the bottom, and the n squared is in the square root sign. So what we're going to get is the square root of 2n squared plus 3 all over n squared. N over n is 1. And then finally, what we're going to have here is we're going to have a square root of, split up the fraction, 2n squared over n squared plus 3 over n squared all divided by 1. The n squareds cancel. This turns into infinity squared. That turns into 0. So we're going to have the square root of 2 over 1, which equals root 2. Okay, so that's the end of this exercise now.